Okay, so what I have here now is what I have here now is a data schema. What is this? Okay, what I have here is a data schema, and then what it basically shows is it shows um, imagine you have a database with multiple tables, right? You can treat a table as a worksheet, right? And then um, you have multiple tables connected in one way or the other, right? One linking to the other, and all within a database. It could even be from different databases, right? So sorry, let me add it. People, is trying to join. I just wish I can add people by default. Let me see. Well, okay. I don't think I have that option. So what this does is that it shows with this it shows us the relationship between different tables in our data set. So right now we have about how many tables? One, two, three, four, five, six, seven, eight. A quick one also. Let me turn on my highlighter. Apologies. Turn on my highlighter so that you can follow my screen easily. Okay. People are trying to join. Okay. So sorry for that. So I was saying that what this does is basically to show the relationship that exists between their different tables. Like here now we have one, two, three, four, five, six, seven, eight, right? Eight tables. And these eight tables are connected in one way or the other. And with this schema, I can link up all these tables if I want. But if you notice here, between each between two tables, between every two tables, there is something here, a label. As you can see here, this one is order ID, right? Between this list order reviews and list orders dataset, there's an order ID. Then between this one and this one, there's also another order ID. But between this one and this one, you can see seller ID. This and this, you can see customer ID. So it varies. It varies, or it can vary depending on the tables in common. Now, what is this thing? What information does that tell us? The label here shows us that between this table and this table, like if I open this data set, which is only orders data set, I'm going to see a column there called order ID. And then when I open this other one called list order payments, I'm going to still see the same column called order ID. Now, with this column, I can join this one and this one. I can merge these two tables together, right? I can merge these two tables together. So that's what the information is telling us. Now, let me open the data set so that we um, can see everything. This is the oldest data set, and then these are those tables you saw me display here. Everything you see here, these ones that look like database icon, right? They represent tables. They represent these different data sets. This one, about eight of them or nine. Yes. Now let me open one of them, which is orders, list orders data set. It will take some time to load because it's kind of a big table. I hope you can hear me. Someone should confirm.
Yes, we can hear you.
Okay. Okay. I'm recording it actually. I'm just asking. It's a big table. Okay. So let me just find it. Now, if you check now, you need to see a column called order ID, right? Which is this one. and then I want to see the relationship between this is the oldest orders data set, and then this is the oldest order payment. So let me open the order payments table now for us to see. um I will open it here. Order payments. Okay, the same. Okay, it's coming up. Okay, this is order payments, right? And then you can see that I also have the same column called order ID, right? So they share these two, the two tables share this data set and share this column in common, right? And if I want to connect these two table, merge this one and the other one and the other one, I can do that. I can achieve that using that common column. Now that was just a kind of a quick intro. Now let's look at what merging is. Essentially, let's look at what merging is. People are trying to join, so let me just add them.
Sorry, I have an idea. If
Okay.
you can make someone co-host, so the person now have people add multiple in, and then
Mm,
you can send with your presentation.
I know. Can someone point me to where I can do that? Because I wanted to. I prefer if someone can assist with that, but I don't know if um, where exactly can I do that?
Go your settings,
It should be here.
the words,
I'm not having that option. I think I'm on their free plan, so
check general, check general.
it's not there.
This one.
So, so let me just do it manually. Mm, Okay. So what I was saying, so I want to quickly give us an introduction to merging data, right? Let me create a new worksheet. What merging data could look like is um, it's just the process of combining two different tables, right? It's the process of combining two different tables in one way that you achieve a final table that contains information from the two tables, right? Now, imagine that you have yeah, let me just copy a subset of this data to make it easy for us to see. Copy this, Control C, then paste it in my new file, Control V, right? Yes, this one is coming from the first table. Then let me go back to the second table, which is order payments, right? I copy these two. I'll just do it randomly for demonstration's sake. I paste that one somewhere here so we can see it. Paste that one somewhere here. Now, what is this showing us? I have two tables. Let me highlight them so that you can to be easy to follow along. Um, I'll put this in okay, this, then this one. I can quickly color this one as a blue. Okay, so these two tables, right? What they represent is that this one to the right contains the order. That's information about the order each customer placed, right? Like we have the order ID for each order that was placed in that e-commerce platform, and a unique number is assigned to it. And for each customer has their own unique identification number that identifies every customer. Now you can see that we have two different IDs. The first is the order ID, second is the customer ID. Why do we have two different IDs for the same table? It's so because a customer can place multiple orders. Like I can, as a returning customer, I can place my first order today. Next month, I place another order. So for the company or the organization to be able to track all this, each order is assigned a unique number, right? And then for the company to also know each of their customers, right, to be able to associate certain actions to with a customer, they have to assign a unique ID to each customer. And the ID to each customer, this customer ID is supposed to be unique so that if there are two different customers that bear the same name, right, they will not have the same ID. Okay, so but then a customer comes here with this so ID, then initiates this order on this so date, right? And this is the order status. Now, coming here, I have another table. This data, this organization wants to maintain a kind of level of coherence in their database. So they don't want to jumble up everything together. Now they have different records. This the one to the left is keeping track of orders. The one to the right is keeping track of payments. Right? You can see that here we have a payment value, right? Amount the customer paid, with the payment installments, the payment type they use, whether credit card, and then payment sequential, then order ID, right? So they want to store this in their respective tables. Maybe the department that handles orders is different from the department that handles the payments, right? But as an organization, you still want to be able to pull information or data across different organizations or units. You, as the analyst, now will be the one to do this job. A, Another easier way to look at this is I believe most of us pass through higher institution and we all belong to different departments. When you come to the university or polytechnic or whichever higher institution, I know in one way you first pass through the admissions and what do they call them? Um, um, you see records, I'm not sure, but admission, you get admitted first, right? And a certain department keeps track of your mode of admission, your year, the year you were admitted, um, and then all those information related to your department and all that. Now, there's another department, there could be another department, let's say the security department, that also wants to have access to student data. Maybe they want to log certain, okay, let me not use crime related information. Let's say there's another department like, um, should I say, um, which example can I use now? Let's say those in charge of payments, right? School fees and all those things. I don't know the name to associate with them. Maybe they just accounts, yes, account department, right? So they just want to know the account department, they are responsible for transactions, making sure that everybody is up to in tune with payments and all that, right? Now, the department that holds information about each student's data, like mode of admission and all those things, is different from their own department. So how would they be able to connect to associate the data about payments of each student to the department? I mean, to the department students' order records, right? Now, I know that for most of us, we had something called a student reg number, right, which is unique to you, right? It normally comes depending on your school. It can come from the year you admitted. Perhaps it can also be information about your department or faculty and all that. So throughout in the whole of the university database, there can only be one student with that particular ID. I mean, with that particular reg number of yours, like, and that is you. So that ID alone can identify you, even in 50 years' time, as long as that university remains, right? So that's similar to what this does for each order. This one identifies the order, right? So that is a quick thing about that. Now, imagine now I want to join this tool. I want to connect. I want to not just see. I want to not just see this order related information. I want to see how the payment method that this customer, let's say this customer was the one that placed this order. I want to see the payment method that they used to complete their order. It's in a different database, in a different table. So I will leverage on order ID to do that. But that's a simple case whereby there is just one, you are lucky enough to have one column that identifies the same information across board, right? Now, there are other instances whereby it is not possible to have just one column that identifies student records. Like in the data set, in that particular data set we used for the hackathon, in that particular data set we used for the hackathon, you would discover that um, for it contained the records for that is a um, child mortality, right? Infant mortality. It contains records for mortality. Let me open one of them for each country, right? contains record for mortality, child mortality for each country. And you see that not just that it contains that record for each country has their own record for each year, right? So it is not just one year record. So for Afghanistan now, you can see that Afghanistan in 1957 they have a record. 1958 they have a record. In 1959 they have a record. 1960 up till as long as the most recent data here, you can see it's going down, which is still Afghanistan until somewhere around here. You can see 2022 Afghanistan, right? So that brings a kind of a unique case whereby if I rely on just the year, if I rely on just Afghanistan, which is this code as the unique code, to connect this table with another data set, which let's say another data set like um let's say like let me open that. It's coming up. I hope it's coming up. Sure. Let me try this one. Okay, so if I have um, since I have multiple records for each country has their own multiple records, right? Which is for different years. If I want to connect it with another record, let's say table for, I want to have record for the same Afghanistan, but this one is on youth mortality. The first one we opened is child mortality. This one is now youth mortality. Let's say I want to see record for both child mortality and youth mortality for Afghanistan, right? As you can see, we still have the same Afghanistan here for different years. So if I want to connect using just Afghanistan as a code, right, I'm going to run into an issue because we will have a lot of duplication, right? We have a lot of duplication. Here is the first case, here is the second case, third case, fourth case, and so. Now, but then if I combine this code and the year, right, I'm going to get something unique. If I combine code and year, that means here I'm going to have Afghanistan 1997. Then let me pair them. Afghanistan 1997. Then where's the other one? Child mortality. Then here as well, I have Afghanistan. If we have okay, where's 1997? 1997 is somewhere here. This is Afghanistan 1997, right? So you can see that this Afghanistan 1997 here is corresponding with this one Afghanistan 1990. Okay, this is 1977 actually. Sorry for that. So let me go back to 1977. Okay, this is Afghanistan 1977. Let me just color it so that we can easily keep track of that. Afghanistan 1977. Then this is where is Afghanistan 1977? Yeah, these two. So it means for this particular record, right? If I want to join these two tables, right? It's going to the best way to handle it is now to combine these two unique columns to give me, I mean, two different columns to give me a unique value. There is no other place, there's no other place, no other combination, two combinations of this column that will give me Afghanistan 1997, right? I hope you are following. Hello, I want someone to unmute to let me know that they are following because I would really appreciate that. Hello. Come on. What happened? I'm speaking to myself. Come on. Hello. Hello. Sorry, I did not really know I was talking to myself. I don't know for how long now have I been off. Okay, sorry about that. I thought I was just check my internet was tripped. So sorry. So I was saying that for us to get for us to be able to combine this table, which is a child mortality and youth mortality, I cannot it's not advisable to rely on this column alone, which is the code for the country, because we have a duplicate, like we have duplicates here, we have duplicates, so many duplicates here, just like we have here. So the only thing that can save me is that I can leverage a combination of of columns, like here now, code and year. So for this code and year, if I have Afghanistan 1977, I can also say Afghanistan here 1977, right? So with these two, I can combine. So this second case is the case of when you don't have one common column that is unique, right? You don't have a common column that is unique across your data. So you can leverage a combination of columns to achieve that. And then you can do that for as long as, or even if it is 5 columns that you need, that you would give you something unique, you are still allowed to do that. Now, Python, whether you are using Python or Excel or Power BI, whichever tool you are using, allows you to be able to define the ID column for your data, right? For the ID column for joining your data, right? So, so far, I want to ensure that I'm carrying people along. So someone should let me know whether they are following at all with what I've been saying so far.
Yeah.
Okay. Now, now there's a number of things for us to take note of when merging data, right? In your data set, you would always have something called a type of a particular table called fact table. We have fact table, we have dimension table, can be multiple can dimension tables or dimension table, right? What is a fact table? Fact table is a table that contains the primary record you are interested in, right? That is like it contains the most important data that you are interested in. For instance, as an e-commerce platform, the example we are using now, the center of everything lies in orders customers placed and all. Like no e-commerce platform opens an e-commerce platform for just keeping record of um, payment type that people use. Of course, payment type is um is a product of is something that emanated from the fact that people are able to place orders, right? So this table called this very one here in our case, back to this where's that image? This very one here, you can see it highlighted in red, right? It's for a reason. It's to tell us that this is the fact table, right? For this entire data set we have. And then it contains the most important data we are interested in. Now, in our own case, for the data set for the hackathon, right, our facts table could be that child mortality table because the theme of the hackathon is on child mortality, right? So that table that contains records related to different countries and their infant mortality rates can serve as a fact table. Now, the other things like the other types of tables you find here are called dimensions table. Dimensions table are those tables that add additional granularity, like they help enrich your data further. They help enrich your table further so that you can analyze your data from different perspectives. For instance, it may not just be enough to have a table containing information about child mortality. So they went further to provide additional data sets that shows us that for each of these countries that even though we have records for child mortality, we may still want to have a feel of what youth mortality is for that particular country, right? We can also have maybe one, they may also want us to, maybe you may also want to have a clue of what the different, like the economic um, income group of that particular country is. Like as an analyst, you may want to associate child mortality with things like what is the country's budget for health, for the healthcare sector, for at least for children below 5 years. Like those could be additional data. Okay, what is the vaccination coverage for that particular country? And then like those other data or tables are coming to enrich your data further. But the facts table is the one that contains the primary information you're interested in. It could be sales if it's in marketing or so, or if it's in the business sector. Your facts table could be sales data, right? Right? Then your dimensions table can be different customer segments, right? Maybe consumers and all that. Then it could also be things like demographics of your customers, like male, female, or region where they are from. Those can come as dimension. But the facts table is the table that contains information related to order. Now, why is this important? It's important because knowing this will help you in knowing how to join your different data sets. Now, given that we have identified what our fact table is, um, we want to be able to retain for most use cases, right? You would like to have all the data in your fact table, right? Then you may want to pull out, let's say it's just payment value you want to pull out from your dimension table to join with your fact table. I want these payment records now from here to come and join with this the information in the fact table. I want to combine that, right? So in this case, there are some terminologies used. We use things like left and right, right? Left and right is dependent on how you call it. Now, let me quickly do a demonstration because I think I've spoken for a long time now. Let me quickly do a demonstration for us to see. Back to this, I want to join these two tables. I want to join orders dataset, orders and then order payment, which is the one we have opened before now. So the order payment is in this, where is it? List order payment. So let me copy it and then quickly load the data as well. So orders payment, let me call it payments df, right? Then, sorry. So let me load this second one. So you can now see that I have the two tables loaded, right? These are orders and then these the order payments, right? So in this case now, I want to merge these two tables, this one and this one. And what does merging do? Merging, when you merge along the columns, right, you are going to end up getting additional columns, right? Getting additional columns. Let's say the last column we have here is orders, order estimated delivery date, right? So if I want to pull payment value, that's the payment value for each customer, to join it with this table, right? So that I can see it here. Then I would end up with an additional column here, right, to the right. So for most to achieve that, pandas offers you a number of like some functions to achieve that. So let me just do that. Let me create a new table called combined or merged. Let me call it merged df, right? Merged df, we use a function called pd dot merge, right? Sorry, let me add some more. pd.merge is a function that lets you um, combine table, right? To have to pull data from one column to the other. So let's say pd.merge. Then if you want to merge, if you are confused and you're on Jupyter Notebook, right? There's a cheat sheet you can use. Just press down your shift key and then tab, and then it shows you the documentation. That's the way to the different parameters you can set. I mean, what is required and what is not required. So you can see it gives you like a brief documentation about the function you want to use anytime you're confused about a certain function. Now let's see what pd.merge does. I mean, what pandas merge does. It merges data frame on named series objects with a database style join, right? Now, a named series object is treated as a data frame with a single named column, blah blah blah. Then, so if you read down here, you're going to see in details what this particular function does. Now, if you scroll down, you're going to see here parameters, what each parameter represents. Now, we have something called left. Left is a data frame. We have another one called right, which is also a data frame, right? So in essence, we want to join two tables, right? So it is up to us to know which one to call left or right, right? So in our case now, we can choose to call the left one. I mean, this first one, which is the orders, the data frame, we can call it left. Then we can now call this payments data frame, we can call it right. It is just for our own sake, for us to know for us to quickly know which table we are making reference to, right? Now, the other parameter is called is how, right? How do you want to join these tables? Do you want to pull data from the first one to the second one, or you want to pull data from the second one to the first one, or you want to get everything from both the first one and the second one together, and so on. So we have left join, we have right join, we have outer join, and we have inner join, and we have cross. right? You know, someone sent a message. What is that? Um, okay, yes. You press down the shift key, then you press tab. That shows you the shortcut to seeing. Yeah. So we have left join, we have right join, we have outer, inner, and cross, right? So here, each of those joins have been defined. So what does left join do for you? Left join means I want everything in the table I called left, right? Remember in our case, we have called this orders data frame left. In this table I called left, I want to retain everything in this particular table. Then, so it says use only keys from left frame, similar to a SQL left join, left outer join, right? So you want to ensure that everything in this left table is complete, right? Then you now want to pull data for all corresponding rows from the second table to come and bring them to the first table. How complex does this sound? I don't know if it sounds complex to you, but it's actually not complex at all. Let me let me use a simple table to illustrate this, or it might take some time to create that particular table. So assuming I have my first table that contains maybe okay, yes, I have a data set that can do that for us. Let me use one that can do that for us. Um, Let me use sample superstore data set, right? Okay, let me open sample superstore data set. It's coming up. So in this table, we have in this very Excel workbook, we have three different tables. We have orders, we have returns, and people, right? Now, imagine I want to to match each order. This table called people only gives me names of different managers for different regions. So I have Andrea in charge of West. This one is in charge of East. This one is in charge of Central, and this one is in charge of South. So I want to ensure that for each order here, right? For each order here, I want to know which manager closed the order, right? I want to have to know which of the managers that closed the order. And then if you come here, you're going to see the common column here, which is um, region, right? You can see region here. You can see region here, right? Just like you can see region somewhere here, right? So if I want to bring this information from this table to this table, right? I can choose to call this one left. If I call this one left, it means it is going to come to this one, pull all the different information like this one now. It picks Andre, it picks Anna here, and then look for region. Anywhere it sees, anywhere it comes to this place, anywhere it sees region as west. Let me filter so that we can see that very well. Filter. Let me just filter for only west. So I can come here and filter for only west. What will happen here? This data set is showing me only sales for West, right? So it means it would come here anywhere it sees West. It will come here anywhere. If it wants to pull data anywhere it sees West, then it will come and anywhere it sees West here, right? It will create an additional column. Anywhere it sees West, it means it's going to populate that column with what? Anna, right? And since I have called this one left, right? It means I'm ending up with a table that is still um, as intact as this one in a way. Like if I check the size of the row currently, it's showing about almost 10,000 rows, right? If I use left join, then as long as there are no duplicates, as long as there are no duplicates in this particular column, then I'm going to end up with the same number of rows in the end. So that is basically what that does for you. Now, in back to our main data set. Now, using the same ideology, right? Right. Using the same ideology, if I say right, then it's going to do the opposite. Being that this time around, it is going to pick, like I'm telling it, retain all the columns or all the rows in the table that I have called right, then pull all matching rows from the second table that I have called left and join it with the table I have called right. I hope this is clear enough. Are you following? Oh, why am I? What is going on now? Internet is just so slow. At least I'm offline. Hello. I really don't know what's going on. Hello. Hello. I want to apologize again. Yes, and I don't know how long have I lost you people now? Because
I won't say it. Hospital you are
huh? Sorry, it was up to 2 minutes.
I can't say, but it take a long while.
My God, more than come on, this is so frustrating. Okay, so in essence, I'm actually recording, so maybe I will still share the recording afterwards so that I believe maybe it will still help. Yeah, so I really apologize for this. It's not intentional at all. So I was trying to explain um, the how, the different parameters you can pass to how. So you can have left, right, outer, and inner, right? So it explained everything here. And then on, on is when you now call the columns. That is the ID columns that you just created. Remember, I told you that you can. I told you that for you to be able to join tables, there is somehow definitely have to be some common columns that you can use to join them. So on is where you now call the common columns.
Sorry, you have to share your screen.
Oh God. All right. Thank you for thank you for that. I don't know why network is trying to frustrate my efforts today. It's fine. Please let me know once you can see it.
Yes, we can.
Okay, thank you very much. Thank you for your patience. It's not intentional at all. So what on does is on is where you now call the columns, the common columns you want to join together. For instance, our order ID is the common column for this, and then this one you can see order ID here. You can see order ID here. So that is going to be our on. Then left on is the label or list array, blah blah blah. Like left on and right on, you can see we have left on here, we have right on here. If the columns are named differently. Let's say this one is named order ID, and you come here, and if this one is named payment order ID, right? Payment order or order payment ID or whatever thing. But then they basically represent the same thing. Then you can say left on is this order ID. Then you can also say right on is now the name of the ID column for the order. I mean for the right table. I hope this is clear enough. Okay. But then if they bear the same cool okay, picture of o- left on and right on, right? Okay. Left on, these are optional parameters. For instance, in our case now that we have the same name for this column is called order ID. And in the first table, and then in the second table, it's still called order ID, right? So in that instance, in that case, in that case, please, I might trip, my network might trip now. So let me just quickly solve an issue. In case, please stay put, I'm with you. Let me quickly solve an, I think my solve is finishing. Okay, so I'm back. So I was saying that in the case whereby the names of the different columns, the names of the ID columns are different for your two tables, right? That's what you now call left on and right on. But in this instance whereby they are named the same thing, which is order ID, I hope you can still hear me. Okay, thank you.
Yes, yes.
Okay, I think I'll be doing it more often because of from experience. So in this example, in this our case now, whereby they are the same name, they are named the same. Like in this orders data frame, the common column is order ID, and then in this one now, the ID column is still called order ID. I don't need this option. Instead, I will just put on. I will now call the name of the ID column. But if they were named differently, then I will not use this option called on. Instead, I'll come and say left on is equal to, that's the name of the column, common column for the left table. Then right on, I will now call the name of the column for the right table. I hope this is clear now.
Yes, please.
Okay. Then the other options, left index and right index, these ones you may not necessarily need them in most cases. As use the index from the left data frame as the join key. If it is a multi-index, the number of blah blah blah. And this does not apply in most cases, just like this one. Then sort. These are other additional options that, depending on you may, for most cases, like as long for the past years that I've been working, I don't really need a number of these options. Then validate this to check if merges of specified type and all that. Now we are going to end up with a data frame. So let's quickly perform a merge. Let's quickly merge these two tables. So I have called the function, I have assigned it a new name that is a merge TDF, which is pd.merge. So let me just specify the parameters. I will now say left equal to, what's the name of my data frame for left? Orders, orders df, right? Then comma, let me hide. Then comma, right is equal to payments df, payments df, right? So the next thing now is now, let me make it easy to read. Remember, you are going to separate every parameter with a comma before you enter the next one. Then the next thing is what? On, on equal to. I'm going to put it in parentheses. I mean, what do you call it? So in what they call it, a quotation mark, right? So here we'll now enter that the name of the common column. On is equal to order ID. It's going to be in parentheses, in quotes. Then the next thing is how equal to. You are still going to open parentheses. That's when we're not going to use left, right, outer, and inner, and all that. So in our case, I have the facts table here. I want to retain all this information, all these records. Then I want to bring the column, the record from this one to join to the left table, right? I have called left as an orders df, then I have called right as payments df. So how I want to call how is now left in my case. So all the anywhere in this place now, whenever what Python will now do is that, or what pandas will now do is that it will come to this column, it will come to this table now, which is right, and then it will pick each of the ID columns here, each of the entries in the ID column. Like here now, it will pick this one, it will pick this one. Oh, I'm still with you. The call is ending soon. Please, if it ends, we will just have to rejoin. I didn't know it would take this long. So it will pick this one, for instance. The other ID here is this one I highlighted. Then the payment type is credit card. Payment is stored, installment is 8, and then payment value is 99.33, right? So it wants to pick all these things and then come to this very table here. It will start searching for this ID that I highlighted. It will start searching for it in this very column. And wherever it sees it, then it will come and place those records, which is it will now assign payment sequential as one, credit card as one, as a payment type as credit card, and then payment installment as 8, and all that. So that is what is going to exactly happen. But if I want to do how equal to right, what will now happen is that instead of picking this one, instead of pulling data from this one to this one, it will now pull data from this one to this one, right? So the difference is that there are times that you may not really have complete, um, you may not really have a, let me use the typical example of this sample superstore I just used. This table now, we have a column, a table called returns, which shows whether an order was returned or not. Not all orders were returned. So if I call this, if I make this one my left table now, and I say join on this one now. If I call this one right table, like this one right table, and I call this one left table, right? And I say how equal to right, what will happen is that I'm only going to have records. It's going to pull all the records from here that have a matching order ID here. And because not all orders were returned, I'm going to miss, like, the record I'm going to have in this resulting table is not going to be as big as the one here, because every order that was not returned will be omitted. I don't know if this makes sense. Okay, thank you. So that is just the difference. So for you to now know whether you are joining to the left or right, you have to know which one is the main table you're interested in, and then which one is the one you're pulling data from. So for our own case now, it's safer to use left. I mean, how is equal to left. So basically, I am done with the most important parameters I need for me to perform my join. So I can just run this table now, and then it has executed. Now let me print it out. df.head. Right. So what you can now see is that if I scroll to the right, I now have those extra columns, which are what? Payment type, sorry, payment sequential, payment type, payment installment, and payment value. I hope you can see now that those are tables from here. This is payment sequential, payment type, payment installment, and payment value. If I come to the main table before I perform the join, I'm not going to see that. They are not there yet, but after joining, they have pulled record. It has pulled record from this one to now combine with this one. Is this not an easy thing to do? It is very easy. That's the main thing I want you to know, that it is very easy to join tables in pandas in Python. And I don't know if I have, at this point, I have made any points to you people, like if I've clarified any confusion regarding that. Hello? Okay. Oh, okay. So that is the most important thing you need to know about. So once you know how to join, then you really know how an issue. Someone sent a message. Okay, thank you. Yes, join, right? Okay. Now, for that particular data set, the issue with that is that in this case, I know I showed you that the exception here is that you cannot just join using one column, because you have records for one particular column. There are a lot of duplicates, right? So in that case, the only difference is that I cannot join it directly because I think the data is very dirty. So that might be issues. But let me see. Let me see. In that case, right, the only thing you're going to change is that when you now say on, what you are going to do is you are going to put this in parentheses. On is now going to be, instead of just one value I entered here, you can put it as a form of a list, right? You now list out the names of the columns. Now the first one is code, right? Then comma. The second one is what? Year. I can't run it, of course, because this is not a table, but I'm just trying to show you what you are supposed to do there. I don't know if you are with me. Now let me open this doc string to show you something. Here, right? Here is where you put this on is the only important thing you're supposed to change there, right? You can make it as a list. It can be either a string, it can be either one value, right? Like one column or a combination of columns. Let's see where it was defined. On label, you can see that on is label or list, right? Label means in this case that we used only one column, it is a label. But if it's multiple columns you want to use to form your ID column, in that case it's going to be a list. And of course, to combine something to make a list in Python is just by putting this square brackets, right? And then you list out the two columns. I hope that's clear.
Yes, yes.
Okay. So basically, that's the most important thing. The other one that looks like it is when you now append. Like when you merge, you get um, a wider, like we have extra column. But then there are other times that you want to place data side by side, one below the other. Let's say you have records, sales records. Let's say you have sales records from January to March. I mean, from January to June, and then you have another sales record from from July to December, and you want to join these two together to now have a complete data set, right? In that case, maybe you have January, February, and all that. Let me just quickly calculate. Sorry. Okay, this February. So the sales 355. Okay, that one is called append, right? That one is about appending. Now this is from January to June, right? Then you now have another one from July to another one from July to August, from July to December. Let me say July, then drag July to December. Now, what is expected is that from here, right, from here down to this place, they are supposed to come and join to continue from here, right, down to make it a complete record, right? I think that's what is expected, right?
Yes, yes.
Okay. So in that case, what you do is another function like join, another function like this thing. That one is concatenate, right? That one is concatenate, and it's still within Python. It's still a Python function. So in that case, if you want to concatenate a table, if you want to concatenate tables, right? What you do is that you say pd dot concat. That's the function. Pd dot concat. Then in brackets, because you are joining tables, the concatenation is going to be a list. So you open your list, and then you enter table one, comma, table two. Even if it's more than two tables, you can still continue like that. In that case, you end up joining these two tables now. With that function, you can join these two tables to give you something like, what is that one? To give you something like this. To give you something like this. Um, to give you something like this that runs till the end. So when you concat, you have a longer table. But when you join, when you merge, you have a wider table. Wide, just think about it, it's going to be wider for merge. Then concat is going to be longer. You have more rows. So our call will end soon, and I would not want us to linger this further. So I would like to spare this 6 minutes for your questions and then answers. Then we can end the call. So if you have any question, you can ask. We can look at it. Does anyone have a question?
Not yet.
Okay. So I guess let me confirm that our meeting was not in vain. That you picked something and that going forward you will not be confused about joining data. Can someone confirm that?
Definitely.
Okay. So thank you very much for joining the call.
Thank you very
All
much.
right. Have a wonderful night rest.
So, how do we get the link to
Okay.
the recording to this?
Okay. I will upload it on YouTube then. I would share the link. All right. Have a wonderful night rest.